Assalamualaikum and hello everyone. My name is Irni Fatini binti Said. Today I will be presenting about the introduction product development process. According to Stuart Parr, this process is a systematic journey that starts from identifying market needs, the designing the product, manufacturing it, and finally selling a successful product. The main goal of this process is to meet customer needs profitably and create value for both the user and the organization. Its success depends on three keys. First, how well the product fulfills customer needs. Second, delivering the product on time. And third, keeping the cost low without sacrificing the quality. Next, let's look at why the product development process is important. PDP helps guide ideas into actual product through a multidisciplinary approach. With a structured process, every department can work in alignment. Some of the advantages include ensuring quality control, improving coordination between departments, enhanced plan and resource usage, helping management monitor cost and progress, and encouraging innovation and continuous improvement.
Okay, I'm Atika Azni. For this slide, I will explain how engineering design play a big role in the cost efficiency, especially using the example of the Apple Watch SE3. First, let's look at the relationship between engineering design and product cost. Engineering design affects everything from manufacturing costs, performance, and even the product's life cycle. A good design helps achieve the desired function while minimizing waste and using material efficiently. For example, the Apple Watch SE3 used an aluminum unibody design. It's lightweight, durable, and cheaper compared to material like steel or titanium. Its modular internal design also makes assembly and repair easier, which helps save time and labor costs. And the efficient layout reduces material use and overall complexity, leading to lower production costs. Next, let's move the design strategy that lead to the cost efficiency. Apple used recycled aluminium and iron X glass, which are not only cheaper and strong but also eco-friendly. Through process simplification, like the unibody design, they use fewer parts and less labor, which means faster production. They also practice component standardization, meaning they share the same chips and display with other model. This lower research, development, and inventory costs. So overall, smart engineer design directly leads to cost saving, better efficiency, and sustainable production. Next, we will look at how company can reduce costs throughout production and product design. Again, using the Apple Watch SE3 as our example. Let's start with the technique and method for reducing production life cycle cost. The first one is design for assembly or DFA. This means creating products that are easier and faster to assemble with reduced labor time and error. Next is supplier optimization. Company work with reliable supplier who can provide quality material at the best price and reduce transportation or storage costs. Then we have robotization and precision, where automation improve efficiency and ensure consistent quality during manufacturing. And lastly, sustainable engineering, which focus on minimizing waste and using eco-friendly material to save costs in the long term. Now, on the right side, it as example cost-effective product design. The Apple Watch SE3. This watch is designed as a mid-range smartwatch that still combines key feature and good performance. It uses all the components which help reduce costs while maintaining quality. It simplifies production process, also mean faster and cheaper manufacturing. Overall, it's a great example of smart design, a product that affordable, sustainable, and profitable at the same time. Thank you for me.
The concept and principle of design for manufacturing using the Apple Watch SE3 as our example. DFM is all about designing a product so it's easy, efficient, and cost effective to produce without reducing its quality and aesthetic. For Apple, this means simplify the watch structure, reducing part count, and making sure every component fits perfectly for smooth assembly. The Apple Watch SE3 also use recycled aluminum and modular components which lower production costs, save time, and supportive sustainability. Now looking at the DMF principle apply. Apple focus on 5 key areas. They minimize part count to make assemble faster, use standard component like 8S chip to reduce costs. Automation play a major role too, with robot handling, machining, and testing ensure precise. Finally, Apple optimized material with recycled aluminum and iron glass, making the watch lightweight, durable, and eco-friendly. In the Apple Watch SE3, Apple used several smart techniques to make manufacturing faster, cleaner, and more efficient. One of these designed for testing, which helped detect defect early through automated check, ensuring consistent quality. The company also recycled all aluminum scrap back into production, making the entire process both efficient and sustainability. Design for manufacturing has a major impact on both product quality and production speed. Because the Apple Watch SE3 has simplified standardized design, Apple can produce watches faster and with fewer errors. Automation play a big role too. Robotic assembly and built-in testing maintain uniform quality and reduce waste across every production batch. Finally, the SE3 itself is a great example of a DFM success. Apple reused the powerful asset process from the Series 8 to cut development costs and casing. It made 100% recycled aluminum precise machine for strength and design consistent. Robot handle polish and engineering flawless finish. As a result, Apple reduced production costs by 15 to 20%.
So, this slide focuses on the overall concept of the House of Quality (HOQ). For the Apple Watch SE3, the HOQ is a part of quality functional deployment process, which helps translate customer needs into technical design solutions. It ensures that every decision in design and engineering reflects the customer's voice. The steps in developing HOQ include identifying customer requirement, defining technical responses, and conducting benchmarking to see how Apple compares with competitors. The next steps are prioritizing key features and integrating them into the design plan. Through this process, Apple ensures that its smartwatch not only meets users' expectations for performance and health features but also align with sustainability and manufacturing ability goals. Moving on to the next slide. This page shows the simplified representation of the House of Quality (HOQ) for the Apple Watch SE3. On the left, we have customer needs such as long battery life, accurate health tracking, lightweight design, and affordability. On the right, they see the technical requirements, how Apple plans to meet those needs, including the use of the S8 chip for accuracy, recycled materials for sustainability, and advanced assembly systems for cost control. The interpretation of HOQ results shows that Apple's strongest customer priorities are battery life and health tracking. The company addresses these through optimized software and improved sensors, ensuring a balance between performance, style, and eco-friendliness. The outcome is a smartwatch that remains efficient, stylish, and true to Apple's premium identity.